Now, for assembly language, it's a it's a low-level language in that it's close to the computer memory as opposed to our way of thinking, our problem-solving way of thinking, which we've done in Python. Now, this is in the revision booklet or the course booklet, page 113. Assembly language, and there we are, Python and VB, and that's a high-level language, and then it converts it into assembly language, which we'll see the instructions in a moment, and then that converts into machine code, which operates the hardware. Now, machine code is binary signals, zeros, ones, one, zeros, etc. And there's a description of it here. Programming an assembly language means we can start to program the hardware itself, whereas with Python and VB.NET and other high-level languages, it's very much up to the compiler and the interpreter and the whole environment of PyScripter, of Python, and VB.NET and the Visual Basic environment, the IDE, to allocate memory resources and so on. But we'll see in a moment with assembly language how we can access memory locations and so on. There's the commands here, input, which inputs a value and stores in the accumulator. Good past paper question had this in from a specimen paper, asked for what did INP mean, what does STA mean. Transfers a value from the accumulator, which is a very important feature, to the random access memory. Now, the accumulator deals with all inputs, all items are inputted into the accumulator, and then we can store them in memory using this command. All outputs are output from the accumulator, and if we want to get something into the accumulator, we can LDA, load the accumulator first of all. Add, as it says, adds two numbers together, and we'll see it adds the accumulator with a memory location in RAM. We'll see this simulated in a moment, a nice simulator used. Subtract subtracts. What subtract actually does is adds a negative number, but it's the same thing. The accumulator only adds, but it can add negative values. So 7 plus negative 5 is the same as 7 minus 5, gives the answer 2. Branch, BRA, that uses loops, but there's no real examples for loops. But it's worth knowing out whether BRA means branch, which means if it's in the loops, it might branch off to a different position if a condition happens. So if a condition such as a value counts down to 0, then branch off to the next part of the program, and so on. Halt, HLT to stop program running, and DAT for variables, setting out variables, and you'll see that now. Now I'm going to use the, there are some good examples here, and I'm going to use those sort of examples now in just a second with the simulator. So input, store the memory location 99, so that's a 99 memory location in RAM. Input another value and add this to the memory location that's already there, 99. Remember, if it inputs, it goes into the accumulator. Output the value from the accumulator, and then halt the program. So we'll see that running now in just a second. So let's go and have a look. So peterhigginson.co.uk is the website that we need to go to find the simulator, and it's /LMC. It's the little man computer. So what I'm going to do, I'm going to just write a short computer program. So I'm going to write, it doesn't matter whether it's in capitals or lowercase, maybe it's best to see it in capitals. So input, now that'll input a value into the accumulator. So I'm going to store that value in memory location 99. Here's my RAM. Now the program is going to fill the first part of RAM. So I'm going to keep the memory well away. I'm going to keep it down here somewhere. So I'm going to store it into 99. If I submit that as a program, you'll see there's the instruction 901, which is input. You don't need to know the instruction 901, but 901 is in fact input, 902 is output. 399, 3 means store, and store the accumulate value, and 99 is the memory location. Again, you don't need to know that. That's an A-level sort of thing. So if I now run this program, here's the program. So it tells me memory location 00 input. So if I run that, now it's happening just a little slow, but what it's going to do, it's going to get the memory instruction, brings it back to the register, which says there's the instruction, there's the memory location, and it now gets, it's after a value. So input a value, so I'm going to input the value 5. Now if I press enter on the keyboard, it's now going to find out, right, it adds 5 to the accumulator, it finds out what was the instruction, store, it's going to number 3, 99 is the address register, so off to the address register it sorts the value number 5. All right, and now it's looking for the next line of code, which I haven't got, so it automatically stops. What I should have put at the end here was a HLT. Oh, I'm going to tab it in. Now, the only reason we tab it in, you'll see later on when I use variables. So submit that and then halt, and that would, and we could run that, okay? So it's stored, remember, it's stored the value 99. Now, I'm just going to speed that up because we don't have to see things actually running. Moving, you don't have to see the control item moving along the bus and go into these places. So just run this. So it wants the number 5, and basically number 5 gets stored in memory location 99, sorry. And if I put 98, that's me thinking ahead, let's submit. So there's the program. All the RAM is cleared in a moment when I run this, and I'm going to store the number 8 in memory location 98, so I can control it using these here. So instead of halt, what I'm now going to do, if I just, the editor's quite easy to use here, so what I'm now going to use, I'm going to use input again. So input, the next value, and I'm going to store that. Oh, in fact, the example says to add, because if I input, it inputs to the accumulator, so the values, the first value I will store in memory location 99. Then I'll input a second value. And I'm going to say add that to the value in 99. So input into the accumulator, store that accumulator value in 99. Then input a second value. So the accumulator will be populated with a different value now. And then it's going to add whatever's in 99, the first number. And then what I want it to do, another command. Oh, we'll see that in just a second. So submit that. There's the program. Let's go a little bit. Let's just go normal and let's run that. There we are. So it goes off to get the instruction, and it comes where the instruction is to input 901. So we'll get we'll input the number 7. So off 7, we'll now go off to get the next instruction, which is 399, which means store into memory location 99. Again, you don't need to know 399 so on, you just need to know these bits here. Now it's going to get the next value, 901, which means input another value. So input another value, we'll have the number 5, so that's 9 and 5. Now 5 will go to the accumulator. So if I can't step through at this point. So if I now put 5 into there, it'll now go and get the 7, and it'll add the 2 together, and we've now got 12. Okay? Now I haven't outputted the values, but it's now got 5 plus memory location 7, 99, the value 7, and we're ready to output. So let's now put that, before we halt the program, let's out that. So we're now going to output that. Notice that these commands will go into 00, 01, they go in consecutive elements of RAM. So it just, the program counter just goes to there. There's the first instruction, next instruction, next. And that's what the interpreter actually, the assembly language assembler does. It puts consecutive memory locations with the next instruction. So they're not found down here or up there or anywhere. It's put here. All right. And in fact, the branch would allow me to go to instruction 53 if it was an instruction in your enlarged programs. So let me now just make sure that this goes fast. So I'm now going to run this. So it's after the number, so I'll put in 9. So the accumulator has 9, memory location 99 has 9, and I'm now going to put in the number 3. So the accumulator will have 3, this location will have 9, but sorry, the accumulator will then have 12 because it'll take the value 9 and add it to it, and then 12 will be outputted. So there we are, we've got those. Right? So we're going to extend it just a little further now with this program. So instead of using just add straight away, what I'm going to do now is I'm going to input, and I want to store this second value. So I'm going to say store that in memory location 98. Then what I'm going to do, because the 98 will have the second value, I'm going to start from scratch, assume there's nothing else in the accumulator. So I'm going to load up 99, and then I'm going to add 98 to it. So it's going to store 99, store the first number in 99, store the second number in 98. Then I'm going to load the accumulator with the number 99, the number that I put into there. And then I'm going to add the location 98, that's my second number, and then I'm going to output the accumulator out. So it's a bit longer, this one, but the benefit of this program is that it stores both values for later use if we need them, 98 and 99. So let's submit that program. So again, here we are, more instructions now in the RAM. And now if we just start, and let's run, well, in fact, let's step through. So if I step through, first is number 6. And so it tells me values loaded into the accumulator, and then the address register gets 399. The next instruction is 901, which is going to be, oh, I should have said, the address said store 6 there. So I got to step now to the next number, which I'll say is 8. Oh, I've got to press enter for that, sorry. Press enter. So 8 goes into the accumulator, so the input value is loaded into the accumulator. Step, so 599, which now says, so we've got 8 into 98, the first number 6 into 99. So I'm now going to do instruction 5, which it says here, 599. So it load the accumulator, right? Sorry, instruction in, it's the 5th instruction, but it's in location 4. Load the accumulator with the contents of 99, number 6. So let's step, so 6 goes into there. Load the accumulator with the contents of RAM address, and we'll step the next one, which is now going to be add the contents of 98, so that's 14, and now we're going to output, which is the next instruction. So step, and we output 14, and the next one will halt the program. Program halted and reset. Okay, so that's how that works. So that's a nice little program to run, and if we wanted to subtract, let's say, for example, we want to subtract the contents, the second number. We have the second number in the accumulator and we take away the first number. So if I want to do 8 minus 6 and output 2, that's the way you load into the accumulator number 98 memory location and so on. We don't have to have 99, 98. It just keeps the data well away from the instructions. We can use any of these memory locations, but we're going to use this. We're going to use 99 and 98. However, now a program, we'll just develop it a little bit further on. So where we've added 2 memory locations now, we're going to now call these variables. So the first number I'm going to store in num1. The second number I'm going to store in num2. And then I'm going to load into the accumulator num1. And I'm going to subtract num2. Right? Now then, that doesn't actually say anything other than just store these values, but it doesn't address these values as num1 and num2 yet until, and that's what I'm going to use the left-hand side for. I'm going to say num1. Oh, let's just bring that up a line. Not that the simulator is quite good, it's a bit foolproof here, but I'm going to use the command dat. Num2 dat. So what it actually is going to say is if I now submit that, instruction 7 is going to be a data. So instead of using 98 and 99, it's going to use memory location 7 and 8 to store the 2 values. And number 7 is going to be labeled num1. So these are variables. In high-level language, we call this x and y, or num1, num2. So I'm now going to run this bit of code. So it's going to ask for the first number, so 7. And notice 7 gets loaded into there. And now I'm going to use the next number, 12. 12 will get loaded into 18. It also goes into the, all right, 7, 12. The result, -5, because it's 7 minus 12. I left it as a subtraction, and output is -5. Okay, now I'm going to advance that just a little bit further because I'm going to have an answer. And again, I don't have to use uppercase, but I'll call this dat as well. So memory location 9 is going to be labeled answer. So what I'm going to do, sub num2, I'm going to store that value in answer, and then I'm going to output the value. So I'm going to store the answer in, let's go and see, it's memory location 10. So 8 will store number 1, 9 will store number 2, or num2, and 10 will store the location. Okay, so you can see how we're using the RAM, the memory. We're actually programming the memory here. So if I run this program, input required, let's put number 13. And 13 gets stored in the 8. And let's now go and put the number 4. So it should put 4 here, and now it's going to put the answer then in there, 13 minus 4, and it puts 9 in there, and it also outputs number 9. Okay, so if I just take that code and put it into my notepad, so it is input. It is store in location. You either use a memory location or num1. Input again, inputs into the accumulator. Store num2. Right, then I'm going to load into the accumulator num1, or later, earlier on it was memory location 99 or 45, wherever the data is stored, but I know that it's going to be num1. Then I'm going to add num2 to it, or if you haven't got a label for it, use variable or memory location 78 if you so wish, you know, if it's stored somewhere in, you know, this location 78. So add num2, because I've got num1 already in there, and then I'm going to output the accumulator. All right. Now I'm also now going to indicate, and I should indent these in so that in the exam it's a bit clearer to see. So when you are typing or writing these out, I'm going to say num1 dat, num2 dat, and answer is also data. So it'll put those in consecutive memory locations and then save that as your examination answer.